Okay, it is time to begin. Should I start the presentation, Vlado, or should I just wait a little bit to see if more people are going to go on?
Hello. Yeah, thanks, Jake. Good afternoon again, or good morning for you. I think the other WebEx meeting session went a bit late, so I expect that maybe still some people will join. But I would propose, in order to be on time, that basically we start with the session. I think for all the participants now, well, you saw basically the hints or recommendations for participants. So please, when you are not speaking, keep the microphone off, and also keep the camera off, so that we don't have issues with the bandwidth. And then when you speak, then you can turn your camera on, and of course your microphone on. The session will be recorded, and later on we will publish the recording of the session in the Inspire YouTube channel. So welcome, enjoy the session, and by saying this, I'm giving the floor to you, Jake.
Thanks, Vlado. Thanks a lot. Okay, so this morning I'm going to be talking about Inspire code lists and how we can improve code lists and code list extensions. When I had originally uh, organized and set up this workshop, it was set to be in Croatia, and the plan was to have all the participants follow along with me and learn how to use our open access tool called ACE, and then all the participants of the workshop would have some time to create their own classification system, be it an Inspire extension or something just for fun. So we're not going to have the chance to do that today, but I don't think that this presentation is gonna go too long. It certainly won't go over time. So I will encourage you all to go and create an account with ACE and to start to play around with that and to share with me and anyone else what sort of classification system or Inspire code list extension that you create there. So my name is Jake McGregor, and I am with Minerva Intelligence. We are a company based in Vancouver, Canada, so rather than being the end of the day, it's bright and early for us here. We're an AI company. We're focused on the cognitive side of artificial intelligence. Our primary applications are in the geosciences, so both in mineral exploration and mining, and also in natural hazard, both landslides, floods, wildfires, hazard and risk prediction. So I think throughout the presentation, you'll see that we have a really strong interest in terminology and semantics and vocabularies, and that's because our technology is built to use semantic networks and really leverage hierarchical classification systems to make predictions. So that's using the semantic stack and using the terms that we use in our data sets rather than trying to convert those terms into numerical data as a lot of machine learning applications do. And because of our interest in semantics and semantic standards, we've come to have a role to play in the Inspire space because we see it as one of the world leading standards and international standards for vocabulary standardization. So although the data schema specifications are of interest to us, it's the code lists that are associated with those that are of primary interest to us and our applications. So today I'm going to be talking about our tool called the ACE. And ACE stands for the Aristotelian Class Editor, and we've given the honor to Aristotle himself. because it was a long time ago that he kind of first started to play with these ideas of classification systems and the fact that we have genuses that create parent and child relationships, and that it's differentia that distinguish what is a child and a parent relationship in any sort of classification. When we're thinking about taxonomies or classification systems, these are just classifications of different things, and they can be real physical things like fruits or animals, but they can also be more abstract things like art or any sort of human classified or grouped set of concepts. Today I'll also be talking about ontologies, and the way that at Minerva we think of an ontology is, it's a way of representing knowledge about a domain or a subject, and oftentimes it's a connection between different taxonomies. So you have a bunch of different concepts in different taxonomies, and they're linked with the relationships between those concepts or entities. And in geospatial data and GIS, we have a lot of these types of classification systems. Here you see that we have land use, geology, transportation networks. They all have classification systems, and sometimes they're flat lists of different terms that can be used to describe the points, lines, and polygons on our maps. And sometimes they're more hierarchical, as they are in geology or in land use. And I'll get into some of the problems and some of the things that we can do with ACE to create those more, I would say, better classification systems for our maps. So the way that we are separating space in our maps is actually really important, because when we're using GIS and geospatial data to make decisions, the way that we've classified it in our original maps is going to influence how we make decisions about what's happening in the space that we have. Some of the problems that Minerva sees in classification systems in general is that oftentimes they're very flat lists, and that doesn't do justice to the reality and the real world that we're representing. We're not showing the complexity and the fact that there are these parent-child relationships between different concepts across the landscape. Another major problem, which I'm going to dive into a bit more today, is the mixing of type of and part of relationships. So in a good classification system, you only want to have one of these relationships present. And typically that's going to be a type of relationship, especially in geospatial classifications. You want to have a parent and a child. You want the child to be a type of the parent. But I'll talk about that more in a second. And the other problem is that a lot of times these are based on kind of expert opinion rather than actually putting pen to paper to prove that what we have in a hierarchical classification is logically sound. Yeah, so let's take a look at some of the Inspire code lists, because these are great classification systems, but sometimes they have a bit of problems. So this is the Hilux hierarchical Inspire land use classification system, and I really like this classification system. It has a good hierarchy. There's a lot of different variety, and it's a really useful classification system. But if we look at agriculture, if we look at the agriculture area of the classification, what we see is that the children of agriculture are agriculture production for your own consumption and commercial agricultural production. And those both make sense. But if we look at farming infrastructure, that's not really a type of agriculture. That's more of something that you would find in an agricultural setting, And so that's probably why this is placed here, because from a spatial perspective, this makes sense. If you're looking at a parcel that is a farm, you're going to have the fields and the barns and something like that. So you're going to be able to split that between, you know, what is the commercial agricultural production, what is the farming infrastructure. But the problem with this is that the relationship is a not really a type of relationship, and that causes problems for reasoning applications. And you can even take a perspective of, like, let's say we were trying to do some sort of you know, typical GIS problem where we're trying to determine the best place to create a new orchard, and we have all the agricultural land, and you know, for us right now, it doesn't matter if it's agriculture for our own consumption or for commercial. We just want to find a good piece of land to start a new farm. The problem is that if we have a set of buildings that are housing a bunch of John Deere tractors, that's not actually going to be a good place to put an orchard. So making sure that these relationships are well set out and in the type of fashion, really important. So that's what I'm going to get into today, is how to solve some of these problems using our tool ACE to create these logically consistent taxonomies or classification systems. So some of the benefits that we have of using the Aristotelian class editor to create our classification systems or to restructure them or to create extensions is that we're using inferencing. So rather than having an expert assert what the relationships are between different concepts and classes in a classification, we're using the properties of those classes to infer the relationships. The other thing, which I'm going to talk a lot about today, is that we can infer multi-hierarchical relationships. So rather than having a tree that represents our classification, we can actually have a graph so that there are multiple paths from the highest level to get down to any single node. The other thing I've mentioned before is that we're dealing with type of relationships, and a lot of times when experts are building these classification systems using our ACE tool, they are being forced to put down the properties and values for each class. And when the inferencing is run, it creates new insights that they might not have thought about before, but when they're forced to really put down and think about what it is that makes every class in their system unique, that they gain new insights into the science of what they're dealing with. So just as a quick example, let's imagine we have 4 land use classes or land cover classes. So we have forest, agricultural, glaciers, and urban. There's kind of different ways that we could split this up, and this is to illustrate the concept of a multi-hierarchical classification system. So if we have the land cover classes, we could split them based on whether they're vegetated or unvegetated. And what that gives us is forest and agricultural on the vegetated side, and urban and glaciers on the unvegetated side. So in this split, we have forest and agriculture as sibling classes, and glaciers and urban as sibling classes. We could also think of different ways that we want to split this very simple classification. We could have it whether it's natural or human influence land covers. And that would give us a different sibling classes. We'd have forest and glaciers together and agricultural and urban classes together. So what ACE does is, rather than forcing you to choose any one of these, it allows you to create a multi-hierarchical system that brings these all together. And what you end up with is multiple paths to get down to a class like forest. And we represent this as a set of trees, but really it should be imagined as a graph where there's only one representation of each class and multiple paths to get to that. So how do we create these types of multi-hierarchical type of relationship classifications? The way we do that is really by putting down all our classes and the properties that we have for that class. So let's say we have a bunch of different vehicle types and we want to classify them. We're going to put down different properties. So those are going to be how many wheels they have, what their energy source is, what the cargo type is. And it could be a whole set of these for complex classification systems like mineral deposits is one thing that we're working on. The number of properties that we have can get quite extensive. And when we fill these out, we get all the properties for those. And then for each column in this table, we take those and build what we call a value hierarchy. And that is an asserted sort of mini taxonomy of the terms that we have in that column. So for wheels, we would split them up and assert a hierarchy that's saying, we have, wheeled and not wheeled vehicles, and within wheeled, we have different types of wheeled vehicles. And this is creating a value hierarchy, and this value hierarchy combined with the properties that we have will be used to inference and inference the relationships and determine the eventual hierarchy of the classification system. The way that logical inferencing is done is based on the shared attributes and the differentia. So here we can see that what differentiates an electric car from a car is that it's really the same thing, except the energy source is different, and that's what differentiates it from a car. Yeah. So if we have all our different cars, we can start to see the power of these multi-hierarchical classifications, because we can split them based on their fuel type, mix them up again, and then split them based on how many wheels they have. And this is important because in Inspire, all the code lists are only single hierarchy; they're not graphs. So using our ACE tool, you can choose which top level split you want to have, and whether you want to classify your vehicles based on their cargo type or their wheels is important, because you need to be not just letting that happen organically. You want to make a decision of what your top level split is going to be if you're going to be creating a code list extension and eventually setting it into an Spire registry of your own, as I'll show later on. So yeah, this is just a bit of background on how our ACE tool was created, or what its purpose is. And now I'm going to jump into the interface itself and show you how to make a small taxonomy. At ace.minervaintelligence.com, and I'll share a few different links with you at the end here. You can come and log in. It's completely free and always will be. You can set up your own account and then log in. And then you'll be, if it's your first time logging in here, you'll have a blank list here. But these are all the different taxonomies or ontologies that you've created. And I'm just going to start by showing you how to start a new classification system. Later on, I'll show you how you can actually directly import all the Inspire code lists and start to specify the properties or create an extension by doing that. But today, I'm going to start with classification that I've already been working on, which is a classification of outdoor living spaces. I think it's, I guess, a bit of the fact that we're going into summer, but I'm stuck at home, and I have my little balcony here, but I'm dreaming of having a big deck or a patio or a veranda. So I was thinking about all these different terms that we have, you know, a gazebo, patio, veranda, all these different things, and what differentiates them. So I wanted to create a classification system of all these different outdoor living spaces. I think it's a good example of a lot of the powers that we have in ACE. So what I have here is you're gonna have to put up with my spelling. I make lots of typos, um, uh, and I'm just gonna plug away at this, and I'll be walking you through. It shouldn't be too long, but I think it'll be valuable because in the end you'll really see the power of creating a taxonomy from scratch and seeing how the inferencing works. So the IRI has to, the only specification is that it has to end in AT, which stands for Aristotelian taxonomy. And this one will be populated automatically, but you can change it to your URL if you want. Here we would typically put what the academic source is. So when I was researching outdoor living spaces, I was looking at some architectural glossaries. I might put links to those, but for now I'll just put my name. The purpose is to classify outdoor living spaces. And the description is a classification of outdoor living spaces. So here is where I'm going to start to put the properties that I'm going to, you know, fill in later on for all my different classes. You don't have to know them all at the beginning of this process, but if you do, you can. So I'm going to start to put mine in here. I have height. So this will be whether it's raised or on the ground floor. We can have size. Material, so what it's made out of, the placement, so this will be like where it is in relationship to the building, its attachment, so whether it's attached or detached from the building, and its covering. I'm going to create my ontology or my taxonomy, and now you'll see here that as I go through this process, I'm going to start to fill out all my classes, and they will be here, just as I showed you in the presentation before, and all the properties are here, and we will fill in the values along here. But the first thing that I want to do is I'm going to take a look at the different properties I have here. If I was missing one, I could add another one in here. An important thing to note is here is the type. So in this case, they're all set to be multi-or, but I might want to change some of these to either single value or joined with and. For height, I can definitely change it to single. I think that all of mine will be single value in this classification, but I'll just leave it as it is for now. And whether you choose or and, that'll change the way that the inferencing is done to create the classification. So here, this is the value hierarchies. This is where I'm gonna put in all the values that I'm kind of like able to use when I'm creating the taxonomy. So for height, I'm gonna add some new values here. I'm gonna put raised and another one that is ground floor. So this is separating something like a patio that's on the ground floor from a deck that is typically raised. And here, as I mentioned before, I'm going to be asserting the hierarchy. So I'm going to put in some specifications that I want to have also some subclasses of the raised category. So I'll also have on top of the building. So that means that, for something like a rooftop terrace, the thing that differentiates that from a terrace is that it's on the top of the building. So I want to have that. And the other thing is that I want to have something that is, so a balcony is typically anything that's on the second floor or higher. So I'll put second floor or higher. And when you're dealing with human constructed things like outdoor living spaces, a lot of times you do have plain what you're going to call these classes and these values, because they are human constructed objects in the first place. Whereas when we're dealing with a bit more scientific classification systems like rocks or biological entities, there are almost always going to be exact scientific terms that you should be using in these value hierarchies. And then I'll click save. I'm not going to deal with size right now, but material, have wood like a deck or hard paved like a terrace. Placement. Oops. Don't want to edit that. I want to add more values. Placement could be around, like a wraparound deck, or within, like a courtyard. And I know this might be a little bit tedious, but this is the task that a taxonomy or a taxonomist has to go through to create a robust classification. And then I also have on the front of the building. So I'll save that. And maybe you're not so interested in outdoor living spaces, but I think you'll really see the way that this connects and shows you how the inferencing works, and also how a multi-hierarchical classification can work. So for an attachment, we can have a detached outdoor living space like a gazebo, or unattached, like a patio or deck. Covering, we'll have open or covered. Okay, so now I have all my different value hierarchies populated. I can go back and I can actually start to create some classes here. So I'm going to add a new term. I'm going to start with the balcony, which maybe you can see behind me. It's filled with a little bit of stuff, my barbecue and whatnot, but we have a balcony. And I can give a description here. You'll see when we pull in the Inspire code list, these are pre-populated based on the descriptions in Inspire. The only thing that differentiates a balcony in my research is that it is on the second floor or higher. It can be made of wood or it could be hard paved. There's all these different things that it could be, but it has to be on the second floor or higher. And this is an important thing. So this is the genus, and for now, I'm just going to put it at the top level. So what I'm saying here is that the balcony is a type of outdoor living space. There are cases where I'm going to want to specify what the genus is, but I'll touch on that a bit later. For now, I'll just put that it's an outdoor living space. And now I'm going to add a few more terms. I have a deck. A deck is raised, so it's raised off the ground, and it is made out of wood. I have a porch, and a porch is, the only thing is that it has to be attached. One thing I forgot to do is to specify that these are both outdoor living spaces. of a patio. Patio is an outdoor living space. It is on the ground floor and it is hard paved. The terrace. So a terrace is also hard paved, but it is raised. And okay, so yeah, I think now I'll just show you. So what we were looking at so far is the asserted taxonomy. There's no hierarchy yet, but if I look at the inferred, you see that these are all types of outdoor living spaces. We don't have any hierarchy other than that because these are all different classes. Now I'm going to add a front porch. So there's two different ways that I can do this, but I'm going to start by showing you that it is an outdoor living space. It is attached, and the placement is in the front. So now if we update this and we go to the inferred taxonomy, we'll see that below porch, we have a front porch. And that is been determined because it is the same classification as a porch, except that it has one more property, so a differentia, being that it is located in the front of a building. The other way that I could do this is that if I was taking the front porch, I could specify that it is actually a type of porch. So this is asserting that the front porch is a type of porch, and then I wouldn't have to put in the attachment classification. And the reason that I would want to do this is because sometimes when you're dealing with these very complex classification systems where there's tons of different properties, and as a taxonomist, you're kind of tinkering with the classification and adding new properties. Sometimes you might not want to always change all of those properties. So if you have a land use class that is determined by 12 different factors of that's what differentiates it from a different land use class, you might want to assert that this rice field is a type of field, and what makes up a field applies to that rice field except for these additional properties that it's inundated with water and grows rice. Okay, so if I update that, you'll see that the same classification will occur. We still have front porch under the porch. So this is the very simple, simplest way of looking at these classification. I'm going to show you what happens when you build out this outdoor living spaces to a bit more of a robust and complete taxonomy. So here, if I look at the inferred, you'll see that we have all different types. We have a deck, both a wraparound deck. We have even subclasses of front porches. And this is one of these insights that I kind of gained as I was playing with this outdoor living spaces classification was I put in the class stoop, and I wasn't even really thinking about the fact that a stoop really is a type of front porch. A stoop, it's a typical outdoor living space on the east coast of North America. It's like stairs on the front of a building, and really it's a front porch, but the height is rising because it's a staircase. There's different ways you could have represented this, but that was interesting for me to see. A lot of this was straightforward. I know that a front porch and a back porch are going to be a type of porch, but I hadn't thought about the fact that a stoop really is just a type of front porch. Yeah. So another thing that I'll show you here is that I created this class called covered spaces. And so that's on a class on its own. Most of the things like a lanai or a patio, that's an entity that exists somewhere in the real world, whereas a covered space, that's kind of a grouping of different things. And I created that to show how a multi-hierarchy works, because what covered space is. It's in any outdoor living space that has a covering, and you'll see that a veranda is placed under here because a veranda has to be covered, but a veranda is also a type of porch. So here we're looking at the same entity, but there's multiple different paths to get to it. Okay, so that is the outdoor living spaces classification. Um, Hopefully that showed you a bit about how the inferencing engine works here. I think I'll touch on that briefly. Um, so when the inferencing engine is run, it's calling a reasoner, and the reasoner that we're using is Pellet in this case, but there's a lot of different types of reasoners that can be used, and actually ACE is set up so that if you have a specific application where you want to use a different reasoner that's going to use different rules of logic, then you can put that in. Yeah, and okay, so now I'm going to jump back out and show you how you can import an Inspire code list into here. So if you go to create a new ontology, you can select Inspire code list. And then you're going to get all the different Inspire code lists. And you have to be careful here because a lot of these, we've just pulled them all in, and a lot of these are actually empty code lists. So that's valuable too, because you can pull them in and then create your classification for an empty code list using ACE. But you also, for this application, I'm going to want to show you a more complete classification. So I'll pull in the Hilux land use classification system. And it's going to populate most of this on its own. The only thing that it's not going to fill out is the properties, because that's your job as a taxonomist to determine, okay, what are the classes, what are the properties that I want to use to differentiate all the classes in this code list. For now, I'll just create the classification. There's a bit of a bug right now where it doesn't populate them all right away, but if you go back and you find that, it'll fill it out. So the other thing that this is just a simple use case base, but I love to, if I'm looking at a classification system in Inspire and I have to use the Spire Registry, it's often very difficult to see what the relationships are between the different classes. So you can't really see or visualize the hierarchy using the Spire Registry. So here you can actually see, okay, what is the hierarchy looking like in all these different classes, and it's going to directly pull in the description of that class. So if you were wanting to take a look at an Inspire code list like this and maybe try to rework it to work out some of the kinks that it has for your specific application, you'd bring it in here, you'd start to add properties, build them out, and then you could infer a new hierarchy based on the properties that you've given all these classes. And a lot of times a good starting place is these definitions. You know, you can take a look at these definitions and that'll give you an insight into what properties you should be putting on those on that class. So that's how you can pull it in an Inspire code list. But the other thing that we have done at Minerva is rather than just pulling in a code list, we've actually created a new extension to a code list. So I'm going to show you, I think this is the, so this is, we were taking a look at the natural hazard classification. I think I can actually show that to you. So if I pull in the natural hazard classification falls within the natural risk zone schema. And we were using it in an application that we were building in Italy, looking at landslide hazard. And when we took a look at the natural hazard, where is it? Natural hazard category, there we go. We were looking at the different geological hazards that they had here, and for landslide, it only went down to landslide, and that wasn't sufficient for our application because we needed to differentiate between a rock slide and a debris flow and a soil slide. And so what we did was we created our own classification system based off of academic research. So this is the landslide classification that we came up with, and it's based on the Varnes classification, which is kind of a universally recognized classification of landslides. But we took what was in textual descriptions in academic papers and pulled those out and used those to describe, what is the rate of movement of a slide, what is the material that's being released, and use those to infer a classification. When we first built this, we kind of went a little wild and created a multi-hierarchical classification. But then we decided that we needed to have a single hierarchy so that we could actually bring that into the Spire Registry and have it play nicely with the Spire code list as an extension to the natural hazard category code list. We chose to use the flow, the type of movement as the first split. So you'll see here that we have the different types of movement and all of these different types of landslides have different types of movements, and we use that to be the top level. So that allows us to split between, all the different flows and the different falls. But we just as well could have chosen the first split to be the material. So then we could have had all the rock, all the different types of movement in rock at the beginning, and then it would have gone into whether it's a flow in rock or a fall in rock. So that was a decision that we had to make when we were creating the landslide extension to the natural hazard category code list, and it's yeah, that's how we chose to create that decision to work with just one single hierarchy where every end node or every single concept is only found once in the classification system. So what we did was we then took this classification system and we downloaded it. So there's different ways that you can download a classification system. For this application, we downloaded it in an Excel format so that we could take it and reformat it a bit into a CSV format that we could be uploaded into our registry instance, which I'll show you in a second. But first, I want to talk about some of the other download formats and what their use cases are. So JSON is really the format that I would suggest using for saving a taxonomy for use internally within ACE. All of the work within ACE is natively stored as JSON. So if you're just saving a taxonomy to be worked on later, or you want to share it with a colleague because they're going to do a bit of work, you might want to download it as JSON, email it to them, and then they can load it into their ACE account and start to work around with it. We also can download it as an OWL file, and this would be used if you were wanting to bring it into a different ontology editing tool. So if you're going to bring this into a tool like TopRate Composer or into Protege, then you'd want to download it as OWL, and then you could bring it into those different tools. And you can either download the asserted or the inferred taxonomy. If you're downloading it as JSON for use later on, I would suggest actually download the asserted taxonomy, because then it's going to preserve all your properties, and then you can use the the inferencing engine within ACE to infer that taxonomy. Yeah, and the same goes for OWL. You might want to download the asserted, or if you were wanting to use the reasoning engine in a different tool, then you could use and you would download the asserted and use the reasoning engine, whatever tool you're going to be bringing this taxonomy into. Another interesting little feature of ACE is that you can open this visualization tool, which will allow you to visualize the taxonomy. I find it a little bit confusing because it's showing all the different properties as well as the classes, and that's really why we're talking about, you know, a taxonomy and an ontology in the same page, because what we're creating is a taxonomy. That's the end goal of producing something in ACE, is to create a taxonomy. But because we're dealing with different value hierarchies that all have their own, you know, taxonomies that essentially are taxonomies, what we are building is an ontology that is used to reason and create the taxonomy. Hopefully that's not too confusing, but that's the point is that we're creating a taxonomy, and we're using an ontology to kind of get there. Some other things I'll point out is that you have your help tool here. We've just updated this with some new information. This has a little bit of, you know, back-end information about, you know, what is an Aristotelian taxonomy, what are we using this for, and then a tutorial about how to go through and create a taxonomy within ACE. So I think one of the last things I'll show you is our Spire Registry. So this is the Minerva Inspire Registry. I don't know if you knew this, but the Inspire Registry that houses all the code lists for Inspire is actually an open source piece of software that you can download and create your own instance of in order to host different code list extensions or schema extensions. So if you go to minerva.codes, you'll see that we have some code lists, and we also have a schema registered. But here I'll show you that this is where we registered and kind of formalized our natural hazard category landslide extension. And it's really important that if you are creating landslide, or sorry, any extensions to Inspire code list, that you formally register it. If we want to maintain the interoperability of an Inspire classification or code list, we can't all be working with different versions of it, even though for specific applications you might need to extend that classification. You should always share that with everyone so that if someone else needs to work with landslides, they can use this extension that we've created here. And so here you'll see that we have all the classes that we were showing in the ACE, except we have also the top classes, and these link directly to the Inspire. They should link directly to the Inspire code list page. Working yesterday. I wonder if the Inspire page is down. Anyhow, I think the other last thing that I'll show you, I can get to it here. So this is an extremely extensive classification system of monsters that one of my colleagues created based on Dungeons and Dragons monsters. I'm not like a nerd like he is, and I'm not totally turned on by this, but he spent a lot of time putting in all these different monsters and classifying them based on their different statistics and whether they're neutral or evil or good monsters. And there are hundreds of different monsters in here, and I'll share the link to this and some other good links on Ace, because whether you're into Dungeons and Dragons or not, I think it's amazing to see what this tool can do outside of an academic setting, because typically we're using Ace as a tool for very academic work. It's work that we use on a commercial level, but it's kind of, taxonomy research work, and to see it being used in the context of classifying hundreds and hundreds of different um, monsters is pretty cool. Yeah, so that's the end of my presentation today. I think I now have plenty of time to take questions, but I'll also one thing I should mention for sure is I'm gonna stop sharing here, is that tomorrow at the same time, my colleague Clinton Smythe, as well as Gio Roberti, David Poole, and I think Matt Harrison as well, will all be presenting um, on Inspire as a framework for artificial intelligence. So that's going to get more into the core of what Minerva does, and how our reasoning applications work, and some of the work that we're doing in the geology world. So I'd encourage you to sign up for that. And now I'm free to take questions. So feel free to type any questions. I don't know if I missed any earlier on. Doesn't look like it. Links to Ace, yes. Oh, okay. I will send those in the chat right now. So that's Ace itself. Here is a read-only link to the monster taxonomy. And if you love outdoor living spaces, here is my outdoor living spaces classification. Thanks, Emmanuel. All right. Database management systems. So that's a good question. I don't have a particular use case where you would, so maybe I should. So when Ace would be a tool that you would be using to create an internal standard that you would want to be using in a database management system. So let's say you had a database and you had a table, then for one column you might want to specify, okay, you can only use terms from this. As in Inspire, like we have elements within feature types that have specific code lists that are associated with them. So this is a way of creating that code list, or that vocabulary that can be used within a schema for that specific property. James Passmore asked, what formats can you upload a code list into Ace? So it's the same as you can download. So you can actually download an Excel format, and then you can work with the taxonomy within Excel, and then you can re-upload that into Ace if you are someone who really likes working with Excel. But you can also upload an OWL or an RDF or a JSON format Ace classification. So it's all the same formats that you can download: Excel, JSON, or OWL. Then you can put those back into Ace. Clara asks, when you have the same feature under multiple streams, can you set the primary way of classifying? Okay, so I think that gets to the question of genuses versus specifying properties. So if you had a something that is like, you know, a main primary subclass, and there's going to be lots of things below that, you might want to set that as the genus, as I did for the porch and front porch example. Thanks, Dave. Can you import CSV's long list of terms to be included in the ontology? Okay, so I think that I'm actually just going to share my screen again one more time so I can show that the way that the Excel import works, because that's something. So when you're downloading taxonomy, you can download it as Excel. I have one of those open. So I have my outdoor living space classification here. Um, sorry, that is my cat's automatic feeding machine. So here you have all the different terms that you have. And so if you have a CSV and you wanted to create a classification system in ACE, what I would suggest you do is start a new taxonomy. Don't put any terms in it. Download it into an Excel format, and then you can upload you can fill out all your different IDs here, the different terms that you're working with, and then you can re-upload that into ACE. It's a bit of a workaround, but it is a functional way of taking a CSV list and putting it back into ACE. And some people, are real Excel whizzes. So we have some people in the office who kind of prefer working with ACE within this Excel format and then re-uploading it to use the inferencing engine. How to handle contradictions in code lists? That's a really good question, because if there are contradictions or duplications, they're going to come up in this process of creating a taxonomy in ACE. And it's going to be something that you're going to have to deal with other people on a committee. If it's an Inspire classification, those are problems that are more bureaucratic than the scientific tool gets to. So if there's contradictions, you'll have to either remove some of those terms or maybe consolidate them and give it a new name. All of those things are possibilities. Clara asks, what do you think the benefits of ACE are over other similar tools? So there are a few different ontology and taxonomy editing tools. I think that ACE is quite simple to use. When you're looking at something like Protege or other ontology editing tools, they have a lot of different powers, and that's great for a lot of applications. But when you're just creating a taxonomy or a code list extension, sometimes you want it to be quite simple. And I think that ACE does a good job of that. You just put in your classes, the properties that are associated with those, and you can infer a taxonomy. So it kind of brings that reasoning capability that is available in Protege and Top Rate Composer, but makes it a little bit easier to access if you're not a taxonomist, you're just a domain expert who wants to make that classification. It is so Edward is asking about the open source license. It is we call it an open access tool, because it is using some proprietary software to make the GUI. We've been talking about whether we want to put it under an open license, but it just hasn't been a priority. We have a lot of commercially viable software. This is kind of a tool that we put out to the public because we want people to work on creating these really robust and logically sound classification systems, because in our reasoning applications, we need those classification systems to be logically sound for us to work with them. And if they have problems, we have to bring them into this tool and rework with them. So we're trying to share this tool with the public to make communities like Inspire more aware of some of these problems that turn up in classification systems. Hopefully one day it'll be available in an open license, but we're not at that point yet to kind of devote the work to pulling out the UI components that are using proprietary software and yeah, we're just not at that point yet. In this perspective, Francesco asks, in this perspective, could it be possible to implement a shared concurrent creation and maintaining process of hierarchies and ontologies? Yes, absolutely. So one of the things that we've been working on here is to actually bring in collaboration so that different people can log in and we have control over changes and multiple people can work on the same classification system and they can do some sort of version control. So again, similar to the question with Edward, it's just not something that we've gotten to at this point yet, but it's something we're looking forward to as well. And one thing that we were looking at was using Git as a way to do the version control and have different people moderate and work on the same classification system. Okay, any more questions? Okay, well, thank you very much for listening. It was great to present ACE to you. I hope you all, I'll put my email in the chat here so that if any of you are eager enough, I would be really interested to see what you are producing with ACE. So if you have the time and you're going to work on something, even if it's just a fun little classification of fruit or whatever it is, please send it to me. I love seeing what people are producing in here. Okay, thank you. I think, Vlado, that's it. Is there anything? Thank you. Is there anything else I need to do here, Vlado?
Not really. Thank you, Jake. I think it was really interesting session. Thank you. Thanks to all participants who were with us. As I said, I was recording the meeting and we will publish it later after the conference on the Inspire YouTube channel. So the only thing you mentioned at one point, it is true, Inspire site is down. So we are trying to resolve the issue. We hope it will work tomorrow at latest, but also before, because it's also the problem for the people then to register for the other sessions. So thank you once again, and then for all the others, we are continuing with the Inspire conference tomorrow at 9 with very interesting Inspire Geoportal workshop. It's a closed one, but for those who have invitation, I think it will be much interesting because of the monitoring and reporting 2020. And then the next session for tomorrow, we continue at 11. And as you said, we have Clinton again, then in the afternoon. So there are I would say, lots of very interesting session during this and next week. So you are all welcome. So thank you all. And by saying that, so I will basically close this session for today.
Thanks, Vlado. Thanks, everyone.
Thank you and bye.